Hey everyone, this is Bhargav Sudhar, and today we will learn a very important algorithm, that is Dijkstra's algorithm. So in this today's session, we will learn how to find a shortest path between 2 points using this Dijkstra's algorithm. Okay, so let us discuss example. So see, we are just directly doing the example, and in this example only, we will discuss the steps. Okay, so the question is, use Dijkstra's algorithm to find the shortest path between these 2 points, that is A and F. So this is the graph. Okay, so that means we need to find the shortest path between this A and F. So this A is, it is the source vertex. Okay, and this is F, that means the destination vertex. Okay, so our source node or destination. Fine. So this is the same graph. Fine. So what we'll do, we'll just create only one table and we'll proceed further. So the first step, this V, that means the vertex we have visited. Fine. And just in column, we will write each and every vertex name. So that means A, B, C, D, E, F. So there are total 6 vertex. So just write this A, this B, C, D, E, F. You can just write this vertices in any order. Fine. So first, see, we want to find the shortest path between this A to F. So we will start from A. Okay. So in a row, the first vertex will be A. Now, what is the minimum distance between A to A? So obviously it will be 0. So we'll put here dash. Fine. Now, what is the minimum distance from A to B, or the distance between A to B? So that is 1. Okay, so we'll write here like this. That is 1 and via A. So we have reached from A to B. We have reached from A to B. So that means we have reached B via A. Okay, and it is the minimum distance. Okay, and this subscript means via A. So 1A. Now the next, A to C. So that is this 3. So that means 3A. Fine. So it is the minimum distance via A. So we'll write this 3A. Now this A to D. Now A to D. Now, as you can see that there is no direct edge. Okay. There is no direct edge from A to D. What we'll write? We will write infinite. Okay. So if there is no direct edge, we will write infinite in each and every cases. Okay. So A to D, there is no direct edge. So infinite. Now in same manner, A to E, we don't have direct edge, so we'll write infinite. And in same manner, A to F, there is no direct edge, so we'll write infinite. So the first step is done. Now what we'll see, now see, as you can see that, just consider this row. Now in this row, what is the minimum distance? So what is the minimum distance? So that is 1A. And corresponding to that, what is the vertex? B. So in next row, this B vertex will be there. Okay. So now, again, this is done. The distance from A to A is done. Now B to B, that is also done. So that is dash. Now B to C. So what does that mean? We are trying to see. We are trying to find this minimum path from A to F. Okay. So A is done. Now we are jump to B. So that means we will look for the minimum or shortest path from B to each and every vertex. Okay. So now B to C. Now B to C. So it is 1. Now see, the source node is 1. The source node is A. So and we are traveling from B to C. So what will be the total shortest distance? So it will be this 1 plus 1. Okay. So that will be 2. And this and we are reaching this C. We are reaching this C vertex via which vertex? That is B. Okay. So this 2B. So that means this 1 plus this box. Okay. So that is 2B. Fine. Then next, B to D. So this B to D, we have 2, but the source node, the source vertex is 1. So that means 1 plus 2. So that is 3, and we are traveling it via B. So it will be 3B. Now B to E. Now B to E, we have 4, but plus 1. So that means this 5 via B, and B to F. So as there is no direct edge, so we'll write infinite. Okay. After this, it is clear. Now, among all these 4 entries, what is the minimum? So you can see that this is the minimum, and corresponding to that, what is the vertex? So the vertex is C. So here it will be C. Fine. So this the 3 will be dash. Why? Because we have already visited A, we have already visited B and we are starting from C, so it will be dash. Now from C to all these other points. Now C to D. Now C to D. So as there is no direct edge, we will write infinite, but it is the shortest path. We've already this 3B. Okay, that is the shortest one. So it will be like this 3B. Okay, the minimum of infinite and 3B is 3B. So I'll just write 3B. Now C to E. Now C to E. So it will be this 5 plus 2. Okay, so it will be 7. Fine. But we have already this 5. We have already this 5 minimum. So we'll write as 5B. Why? Because see, we are reaching E via C. So it will be 5. How? This just consider this path. So that means this 1 plus 4. So A, B and E. So 1 plus 4, that is 5. And here it was 7. So that is why we have written 5B. Now last, C to F. C to F, as there is no direct edge, we will write infinite. Okay. So now in this row, what is the minimum weight? So that is 3B. So just mark it. Now corresponding to the vertex T. So that means next point is T. So the traveling of A, B and C is done. So next, so this all these entries will be dash, okay, and D to D, it is obvious. Now D to E. Now D to E, that is 7, and 7 plus this minimum, that is 3. So 10, but we have already minimum 5. Starting from A. How? We are trying to reach E. So that means this ABE, so that is also 5. The minimum is 5. So no need to go via D. Okay, just go via B. Fine. So it will be same as this 5B. And last D and F. This D and F. This minimum is 6. Okay. And 6 plus 3. Okay. So that will be this 9. And we are just traveling this via D. So here the subscript will be changed. So that means 9 and D. Okay. Now among all this 2. Okay. What is the minimum? So that is 5. So, and corresponding to the vertex, it is E. So now we will start from E. Fine. Now E. So you already visited this A, B, C, and D. So it will be dash like this. And E to E obviously dash. Now E to F. Now E to F we have 2 and plus all these previous weights. So that will be 5. So it will be 7. Now 7 and 9. So what is minimum? So obviously it is 7. So we'll write the 7 and we are traveling via E. So that means this 2. So what is that path? Okay, that we'll discuss later. Now as it is the last one. So it is 7E. So this is how you can create this table. Fine. Now how to find a path? Okay. Now see, just consider this 7E. So what does that mean? To reach from E to F, the minimum weight, that is 7. Okay. So 7E. Now corresponding to the vertex, now see, this will be the shortest path. How? See, this is 7E. So what does that mean? The minimum weight of this path from E to F, it will be 7. How? Now 7, we are traveling 7 via E. Now corresponding to this, what is the vertex F? And so that means we are traveling F via E. So FE will be there. Okay. Now consider the E column. So in E column, we are traveling via B. So that means E and B, that will be connected. So that is 4. Now consider the column of B. So column of B. And we are traveling B via which vertex? That is A. So it will be A. So A, B, E and F. So 1 plus 4 and plus 2. That is 7. So minimum is 7. Again I am explaining. See, this last square. So 7 will be the final minimum distance between this A to F. Now see, this 7, it is what? That is A to F. So that means this F will be there. Okay. Now we are traveling F via which vertex? That is this A. So E will be there. So EF, just draw this EF and the weight 2. Now just E, via E. Now just consider the column of E. So the column of B. So that means we are traveling E via which vertex? B. Okay, so that means B and E has to be connected. Now consider jump to the column of B. So, and we are reaching B via which vertex? A. So that means A to B. So we have covered A to F. We have find the one path which is shortest. So A, B, E, F. So this will be the path with the minimum distance, that is 7. Okay, so this is how you can find the shortest path using this Dijkstra's algorithm. Okay.